Thanks all for coming. It's nice to see such a full room. What I'm going to talk today about is continuous delivery and continuous deployment, and specifically, how do we streamline security testing as part of that. This is a subject I've been working on a lot in the last couple of years. I think it's where our industry is going, and I think there's a lot of lessons to be learned, even if a lot of us are not there yet, and I'll talk about that in a minute. So for those of you who don't know me, I work today for Synopsys. I joined Synopsys through the acquisition of Seeker, which was my company. I've been doing cybersecurity for over 20 years, mostly in application security. I've had pretty much any possible role in this space. I've been a pen tester, I've been a consultant, I wrote code, I worked for a WAF company, and now I work for a company that does a lot of application security testing. And so I've seen pretty much every side of that. I think for the last 15 years, we've been preaching about security having to go into the developers, and today we're at the cusp of this happening with continuous integration and continuous delivery. I'll explain why. Deep down, I'm still a hacker. I like to break things. I like to hack things. I don't do it as much as I used to. Life, you know. I'm also a long-time OWASPer. I've been with OWASP since it started in 2002. So good to have you all here. I'm also a photographer, and because I never get invited to speak about photography, I always plug my photos in my talks. So what can I do? Apparently, I'm more interesting in security. So this was taken in last DEF CON. If you remember last night, who here was in DEF CON? Do you remember the crazy windstorm the last night? So I was at 52nd floor in my hotel and got to take this picture. Okay, my commercial plug for the day, Synopsys, the company I work for. If you still haven't heard about us, you should. We bought pretty much everything around. We have static analysis and software composition analysis and professional services and managed services, and you can see everything here. And if you want to hear more, we have a booth, and that will be my commercial plug for the day. So what are we going to talk about? Starting with an introduction. Oh, we're already in it. I'm going to talk a little bit about what is CI, what is CD, and why do people confuse them, and what's important and what's changing. I'm going to talk a little bit about the key principles of building security testing into CD. And then I'm going to dive a little bit into the notion of testing tracks or parallel tracks and gates and how we use them. And finally, talk a little bit about A/B testing, which is the pinnacle of continuous delivery. So the challenge, continuous everything. So everything today is continuous. Continuous integration, continuous testing, continuous delivery, continuous deployment. You find a lot of other buzzwords around, but it's really about the automation of that process of software building. And I've seen different ways of defining continuous delivery and continuous deployment. But for the purpose of this conversation today, and for a lot of things, it's the same definition Atlassian uses, for instance. Continuous integration focuses on the first part, which is code, build, test in a continuous manner. This is not new. I think almost everybody today is doing some form of continuous integration, at least a nightly one. How many people here have continuous integration in the companies they work for? See, it's a pretty good room. We've been doing continuous integration 15 years ago already. It's not new. So what's new about it is that the testing is getting better, which lets us move on to what we call continuous delivery. Continuous delivery is defined as being able to not just integrate a working version, but to deliver a production-ready version in an automated fashion, right? And so it means that we can deploy to test. We have automation to deploy our software to test, and we have a full cycle of acceptance test, regression test, whatever you want to call it, a full functionality test that can say go or no go on our application. And at the end of continuous delivery process, we have a working version that can go to our customers. Now, continuous deployment is just the next evolution of that, where we also use automation to push that to our customers. Now, it's important to understand that continuous deployment is a luxury of somebody in the cloud. If you ship your software, if you send it to your customers, if your software is an app on an iPhone, right, the update has to be manual anyway. But if you live in the cloud, then you push software into production. And I'm going to throw some big names, but I think if you've had a chance to go to conferences where people talk about software development, there are names like Etsy and Netflix and Amazon and all of these great cloud vendors that building the right continuous deployment platform allowed them to be so fast and to beat their competition. And so continuous deployment and continuous delivery, it's not just a cool technology software people thing. It's a business advantage, and that's why we want to support it. So I took this from Wikipedia. I don't really love this diagram, but it has some point about showing how that works, right? We push some things in, something fails, it goes back. We push some more things in, we pass, we can move on to the next stage. We push some things in, fix it again, and so all the way until we get to deploy. Now, if you look at some of the big names I mentioned that take continuous delivery and continuous deployment to the extreme, we see companies that have multiple production updates per day. And when I say multiple, I don't mean necessarily 4 or 5. It could be hundreds. It can be thousands. And the reason they do it is because they have multiple CI streams. What does it mean? It means that they have different parts of the organization working on different parts of the application, and each of them can push an update separately. And so each of them pushes an update maybe every few hours or every couple of days. But between all of these multiple streams, you can get hundreds of updates every day. How do you manage that? It's hard, and that's what we need to do, because we need to make sure it's secure, but not to stop the process. Another thing we see, and I'll talk about it near the end of the talk, we see A/B testing. And when I say A/B testing in the context of CI/CD, I don't mean A/B testing to say, oh, does this converge my users better than this? A/B testing in the sense that I can push my updates, my changes, gradually into a sort of a petri dish of test servers that run in our production. And I'll explain more about it later. The other thing we see, which relates to that, is microservices. Our applications are being broken into a lot of small microservices that supports having multiple streams. Each service could be the work of 2 developers, not 200, and they can update it on their own without interfering with anybody else. Is it a mess? It sounds like a mess, but if you look at some of these great places that work this way, they produce software better than anybody else in the world. So we want to do security in that. One of the things that are really important to understand here, that this thing has a life of its own. And what do I mean a life of its own? The CI/CD pipeline, the DevOps people, the people that build this continuous delivery, they build a machine that has its own momentum, and it's working. And if you want to be part of that, you have to be part of that. You have to join them and work with them. If you're going to be the security guy that comes and says, oh, we need to do a pen test, and here's a report with 20 findings that you need to fix before we move on to the next step, that doesn't work anymore. It never really worked, but it doesn't work anymore at all, because we have to be part of that. Security has to be part of that process. It has to be integrated into the process. It has to be inside the DevOps tool chain, or you're out. And whenever we go to customers, whenever I talk to customers, the first thing I do is help the dev and DevOps and security people talk together. If they're sitting in 2 sides of the rooms and shouting, don't get to any of the next parts, because they're not going to work. You have to solve this problem first. You have to be part of that. But we see a bigger willingness to adopt this. And we're going to show you some of the things that you can do to help adopt that. So there are a lot of buzzwords around CI/CD, but DevOps is a key buzzword. If you don't have DevOps, you probably don't have CI/CD. Not because it's an official requirement, but because DevOps is the culture that enables integration between developers and IT, which you need for the deployment, and security, which is DevSecOps. So make sure you become friends with DevOps. Make sure you explain to them why Sec is part of DevOps. We don't need to call it DevSecOps. It's just part of what they need to own. So automation. Clearly, doing things that way is not going to work for you. If you want to work inside a CD machine, everything you do from a security standpoint has to be fully automated. Fully is a big, important word. If you have something that's not fully automated, take it outside, do it on the side. If I went to a customer and was like, yeah, we run this static analysis every night, and then we review in the mornings all the false positives. It's like, yeah, maybe that can work when you have one build per night. It's not going to work in a real CD place. Repeat, repeat, repeat. So it's not enough to have automation. It needs to run all the time, and it needs to be fast to support that, and we'll talk about it in a minute. But you have to make sure that everything you do is repeatable and is repeated all the time. Code changes, code moves. The only way to make sure we stay secure is to repeat everything. Shift left, probably the most abused buzzword in the world, especially as there is no more left, right? It's this wonderful little infinity loop. But Alt Control, change the control, change the ownership of people who run security testing. It's not owned by security anymore. You can guide it, you can monitor it, but the people who run it, the people who control it and run it and use it every day is the R&D organization, the engineering organization. Now, this is one of the most important things, and I'll expand about that in a minute, but parallel tracks at parallel speeds, meaning we have different tracks that work in parallel, and they have different speeds that we can do things fast or deep or for compliance and audit needs and so on. And we have to find the right balance, and that will be what I'll talk about in 2 minutes. Gating. So I hear a lot about that. A lot of people in the industry are talking about gates, control gates, right? If I have a critical finding, break the build, block the release. Gates are great. It's part of continuous delivery at its essence, right? If something breaks, if something's a blocker, you break it. But you have to be very careful with that. Security people tend to be very totalistic about everything. Ooh, there are vulnerabilities. We don't go out. We can't be that. We have to be practical, and I'll talk about risk in a second. So you have to accept some risk. And that is a very important thing to understand. We all have vulnerabilities. Every application in the world has vulnerabilities. Don't think that if you had a waterfall system and you've spent 4 weeks on security testing, you found everything anyway, right? We know we have risks. So we have to learn to live with risks. CI/CD has risks in it in a lot of ways. They also have risks of bugs, right? When you push software every few hours, there's a chance for bugs. There are ways to manage those risks and to create the compensating controls. We need to learn to live with it. Okay, so testing tracks. So if we go back to the diagram of continuous integration, continuous delivery, and continuous deployment, basically, we want to find a solution that lets us test things along the pipeline so we can get to deployment with pretty robust and secure software that is inline. It's fast, it's integrated, and most importantly, it does not get in the way. You know why? Because if it gets in the way, it's not going to be in there. You're going to get kicked out. So how do we stretch this green as far as we can get? So if we are here, we have a pretty good coverage, and I'll talk about that in a minute, what type of technologies and solutions you can use. But you have to understand, not all of these technologies and solutions are necessarily going to give you the full analysis that you want. Is that a problem? No, because it's a balance, it's about risk management. So we have a parallel track, which does deeper analysis, which works on the side. What do I mean on the side? This is your CI/CD pipeline. You do something here, you test it here, it passes, it moves here, it moves here, it moves here, it moves here. That's only the green tools and processes. This happens on the side. Let's say you found something here, and you did a full build static analysis. It took 6 hours. It's already in production when you discovered the vulnerability. Is that a problem? Well, theoretically, but we live with that. So we create now a process to fix that in a certain fixed time to push the fix back into production, because we now know there's a problem in production. And then we have the third one, which is what we're used to, which is the even slower process, which could be weeks, pen testing, auditing, the things that we want for compliance, the things that we want to make sure in the last mile that everything that's on production is running. So we have that in here. So if we break it down, if we look at the things that want to run in the fast track, they have to meet a few criteria. So they have to be fast. Speed has to be instant. Why? Because developers are very impatient, and they have a lot of time pressure, and if we take too much of their time, they're going to kick us out. Remember, we want to work with them. So it has to be something that works really fast, and I'll give some examples in a minute. It has to be fully integrated. Don't bring them a new UI. Don't bring them a new product. Don't bring them a new tool. They're going to throw you out the door. It has to be something that comes through their IDE, through their Jira or ticketing, and through their normal workflow. It has to be easy. What does easy mean? Again, it's inside their UI. They know how to use it. It's easy. It has to do not require any security expertise. And don't start with training. I'm a big fan of training, don't get me wrong, but I don't think training is going to turn developers into security experts. They will not be security experts, and they will not like us to expect them to be security experts. So it has to be for dummies in security. Relevance. So the findings, the things that we give them have to be relevant, meaning they're accurate and they're real and they're things that are worth their time in fixing. If we hammer them with thousands of small issues that nobody cares about, again, out. And it has to be actionable. Whenever we find something and we tell them, here's a problem, they need to be able to fix it. Oh, yeah, here's a problem. Here, copy paste this, fix, done. 2 minutes, done. So what type of technologies or tools we can put in these spaces? So obviously, when we look today at the market, there are 3 main areas of testing that people look at, right? There's static analysis, there's dynamic analysis, whether it's DAST or IAST or whatever way of running a testing application, and there's software composition analysis. And we obviously want to do all of these in our pipeline, but we want to find the right flavors of those that can work fast. We all know static analysis can be slow, sometimes hours. We all know static analysis can create a lot of noise in some cases. So we need to have a lightweight version that runs inside the IDE as a spell checker. And we see more and more players in the market doing this today. And why they're doing it? Because it's the only thing that can fit here. So if I'm a developer and I code, and I get a little marker that says, oh, here's a problem, click, info, click, fix, copy, paste, done, easy. I get it into my workflow. Training, of course, but as I said, don't expect that to be something that will turn them into experts. And then we can do incremental static analysis on the build server. So whenever you check in code and you build, you do an incremental testing. Incremental testing can take minutes or seconds if it's really good. And so it's fast. Don't expect to be able to do a full static analysis of your entire code every time you build, because that takes too long unless it's a really, really small application, right? So is it bad? It's not bad to do incremental analysis. It's not bad to do ID spell checker. It doesn't find everything that a full analysis finds, but it's usable in this process. And then for testing of the dynamic side, you can use IAST that sits on your server. IAST, Interactive Application Security Testing, if you've never heard about it. Basically, you have an agent that sits on the server, and while the functionality testing of your CD works. It monitors the code in runtime and finds vulnerabilities, right? So this, again, happens in the background. You don't feel it, you don't see it. These are the things that you can put into your CI/CD. And for these, and we'll talk about gating in a second, you can create real-time gates. So if one of these finds something critical, you can block and prevent it from moving forward. But otherwise, you let this go. And from a risk management perspective, this lets you get rid of a big chunk of your vulnerabilities. So then, you want to find the rest, right? We can't just get the big chunk. We want everything, or, well, everything we think we can. So we create a second track. A second track lets us do things that are deeper and can take hours or maybe days sometimes. So that means a full build static analysis on a sample build once a day, right? And DAST scan can be 2 or 3 days sometimes, but tests the entire application. But these happen on the side. And what do I mean on the side? They are invoked into a different environment or a different set of servers, and they do not interfere with the approval pipeline of the CI/CD. So even if I find something critical here, it can't block the build because the build was already released 2 days ago maybe, right? So now I have to create what we call soft gates, which is essentially a process to fix that in a certain amount of time. And we'll talk about that. But here is where you can put all your heavy lifting tools and managed services and whatever you use today to make sure that you have a higher rate of findings. And then finally, and this is usually the part that is still owned by the security, because as I said, security can't drive a lot of the stuff in the beginning, but they still need some ownership because they have responsibility, right? Liability. So in here, we can put all the things where we test full binaries and we do penetration tests and we can test it on production. And it's always a good idea to test on production once in a while as well. You know, see nothing slip, nothing changes. Maybe there's a problem in the push process and the versions that get to productions are not the versions that you've seen before. You know, we can never be too sure. Of course, you don't always have to put all of these controls in place. And you can make your own decision based on your the application sensitivity and so on. But this is how these things fit. And these have to be in a slower path. So I want to talk a little bit about risk before I'm moving on to the gates. So we have to manage risk. And I think one of the biggest problems of security people in general is a lot of us come from a technical background. We do a lot of pen testing. We tend to look at things as hackable or not hackable. It's a black and white sort of thing. But the reality is businesses work in a risk environment, and everything is a risk. And one of the things we have to understand is what kind of risk we're willing to take and what kind of risk the organization is willing to take. And that's not your responsibility as security people. First, you have to understand how much risk the organization is willing to take, and then how much of that is security risk. But one of the things you have to understand is that security is only one risk out of many, 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 many risks an organization faces. And I see a lot of people, they forget that the biggest risk, especially for a tech company, is a slow go-to-market. That's a much bigger risk than security. If you're not going to be out with your product on time, oh, it doesn't matter that it's not going to be hacked because nobody's going to be using it because everybody's going to the competition. So yes, you're security people. You're supposed to manage security risk, but you have to remember that you work with a team. And so now, let's talk a little bit about risk. One of the things I'm always furious about when I go to meetings with some consultants is they tend to talk about findings in a very black and white way. Oh, it's a SQL injection. It's critical. Is it really? It's a SQL injection on a backend server after a login page that only admins can do. Is it really critical? No. It's bullshit because there is no risk there, right? So we have to be able to understand risk. And we have to focus when we want to be blocking and disturbing and interfering with getting software out. We need to make sure that we know what the risk we're talking about. And there are different levels of risk, and they're classified here. But it's really the exploitable vulnerabilities that are on a public front end is what you care about in terms of being the bad guy and stopping things. And then all the rest, they have different levels of risk, and you have to define that again, of course, per your organization. But once you understand that, you can be a lot more efficient in building your gates. So what is a gate? A gate is basically a checkpoint along the CI/CD pipeline that says go, no go to the next phase, right? It could be a functionality gate, it could be quality gate, it could be specific, like I don't go to the next step if the login page doesn't work. That makes sense. Or I don't go to the next page if I have more than 1,000 bugs in my system, open tickets, and so on. There are lots of different gates. Some of them are security gates. Now, there are two things you need to remember when you look at security gates. Be practical and think about risk, okay? Try to be positive and not negative. Don't be the sheriff. Don't be the person that tries to block. Be the person that tries to enable. And by all means, don't cry wolf. And when I say cry wolf, I say, oh, we can't go live because this is really, really bad and this will destroy us. And then somebody else makes the decision to go live, and then nobody ever finds this. There's a pen test that don't even come up because it's something internal. And you end up as the guy who can't be trusted to make any important decisions. So I mentioned that hard gates versus soft gates. So hard gates are easy. They're gates, right? They're open or closed, and if we don't meet them, we don't do anything. Think how you can live in a soft gate world. And what is a soft gate? A soft gate means I'm letting this pass, but I'm putting a process in place, in motion, that has to fix this within a certain amount of time, right? We have a medium level finding, and we want to start pushing this version to the next full integration testing. That's fine, but you have to fix that within 24 hours or 48 hours. And again, I don't like to give numbers because the numbers depend on the entire speed and velocity of your organization. But the guys building the CI/CD will have their own mechanisms for what has to be done in what level of times, what blockers get fixed in how long. Just ride on that, but put in the soft gates, because then you're part of them and you're enabling them to move forward while fixing that. It's amazing to see the velocity at which teams like that operate. They get something and within 2 hours it's fixed, right? And if it's not fixed, it gets escalated, and then you can block, and that's fine. But you give them the opportunity to move forward, because breaking a build, breaking the process in a machine of CI/CD is bad. So I personally like to put hard blocks only on two things. One, if it's a really critical public finding, a SQL injection in the login page that you can circumvent login. Okay, yeah, that's a blocker. We can go on with that. And then if there's anything that's hard on compliance, because compliance is a big legal risk rather than a security risk, these can be hard gates. All the rest, put in a soft gate, put into easy motion. Okay, I'm starting to run out of time. So last thing I want to talk about before we go into questions is A/B testing. So what is A/B testing? So the term A/B testing originally was used to describe that I try two different functionalities on my website to see which one gets better user traction or convergence into buys. But A/B testing is now part of continuous delivery. What does it mean? It means that instead of having a test environment and a staging environment and all that, I just have one environment, which is my production environment, that has hundreds or thousands of servers. And I push things onto it gradually. What does it mean? I have a new feature. I push it to 1% of the servers. This 1% only gets traffic from my beta testers or from my test automation. And then if it passes a certain amount of time and nothing important pops up, it gets gradually propagated to the next set of servers that now has maybe all my high-end customers that are willing to participate in the trials. And then I push it to 10% of the production customers and see that it works and nothing happens and so on. Now, when you have multiple CD streams, they start getting pushed on different servers in different ways, but you can control traffic. And again, that's not your role as security experts to manage that. The DevOps team, the CI/CD team is building that. If you want to hear a good talk about it, there's a company called Wix. They do websites. They have something called Petri, which is their A/B testing platform, and they have a really great talk that explains how they build it. You don't need to build it. You just need to use it. And when first I talked with security people about that, they were horrified by that, right? Because the lines between production and test are gone, and then every piece of new code that haven't been tested yet goes on production. That sounds like a nightmare. But it's not really, because it only goes on specific servers that only get specific traffic. The hackers can't necessarily get there. And what you need to do, you need to embrace it and not fight it. And why do you need to embrace it? First of all, because if you don't, again, you'll be the problematic dude. But also because A/B testing offers the best testing environment. And I want to explain something on this. How many people here have done pen testing or security testing in some capacity? A lot of you. How many of you got to a pen test and got a system that was with test data not functioning, or something was down? Almost everybody, right? Because that's how it is. Test environments almost never replicate the real world. This replicates the real world. You get a fully functional environment, and you can run security tests on. So as long as you get to be part of the A/B testing train, you can use it. And again, it's about managing risk. So you build the policy, and you manage the exposure, because we know that the first step of A/B testing is only getting to the 1% of the automated testing servers. So that's fine. There's no risk here, right? It's not exposed to the internet. And you can block the next propagation if during that test automation you find something bad. If you don't, you let it go. Now it's on 5% of the servers. Are you exposed to hackers? Maybe. But if it's 5% and it's usually done to some of your better customers because you can trust them and so on, then you're still not very exposed. And in that time, you get great coverage. If you use IAST, for instance, coverage is a big deal. You need enough traffic to test your server. So this lets you get better security testing and be part of delivering software fast. So I hope that was helpful. We have a few minutes for questions.
I got a quick one.
Yeah.
3 slides back, it said works with.
Yeah, I noticed that. Oh, a word got erased.
Okay. I didn't know what the words were meant to be.
Works with the team.
Oh, okay.
A bug in the. That's what happens when you do continuous delivery of presentations.
What is your view on rollback changes?
On what?
Rollback changes.
Rollback changes. So in some cases, this process requires you to roll back, right? Let's say you started, well, arguable, but let's say you started with an A/B testing propagation, you got to 10% of the customers, and then you found a critical bug, like a really high-end critical bug. Then you will want to roll back the changes because you don't want to have a highly critical bug on 10% of your production servers. But it's a edge case.
Is it easier to fix it or just to actually roll back?
So it depends on the organization. Some organizations are really good at producing fixes really fast, like hours, but not everybody.
So you got 2 cultures to deal with, at least. One is sort of the development community, getting them to buy into this, but also the rest of the security team. Any hints on both of those? Either of those?
So you need to have the organizational culture first, right? If you look at the companies that really work CD, right? Again, the ones that are at the edge, Netflix, Etsy, and those. The whole org is built around that. And so the security people, have to be built around that. If they're not, they go to another place. It's harder to do in an existing organization that wants to transform into CI/CD. And what we see, a lot of the organizations that do DevOps transformation and CI/CD, they're really just scratching the CI part of the deal, because getting there is a huge cultural shift. It's not, and it's hard for developers too. Think about it from a developer perspective. Knowing that you have 4 hours to fix something and push it back into production, that's not normal for a lot of developers. But it's where the world is going. 5 years from now, 10 years from now, 50% of the orgs will be like that. Yes?
So false positives in CI/CD pipeline. When you use tools, how do you deal with that? I'm sure you get a lot of false positives. So how do you know?
So you tune the tools.
You can tune the tools, but
So again, depending which tools you use, but you tune the tools to show you only the high confidence stuff, which means you're going to get false negatives too. But that's fine. False negatives are better than false positives in a CI/CD pipeline. I think we're out of time. Thank you, everybody. And you're welcome to reach out to me if you have any further questions.